Alright, so in this video what we're going to talk about is step logic, and we're going to take it a step further and we're going to actually answer some questions that actually got asked. So as far as the way step logic would actually work and how it would actually work with a PLC. So when it comes down to it, you, like, say for instance you're still communicating with your drive, your VFD, your Powerflex 525 through Ethernet. You can still do your start, your stop, and your clear through your actual Ethernet control. So you can start the drive, you can stop the drive, you can stop everything, you can clear everything. And notice every time you stop the drive, it would stop your actual step logic too. Now, one thing I want to note too is if you have speed controls inside of your actual PLC, they will be ignored if a certain parameter is actually being used inside of your actual step logic, right? So if you're using step logic, if I go into CCW and we go into step logic, I can show you this. If we go into general basic parameters, basic programming, if you go into parameter 47, if the speed reference number 1 is going to be set, if you're using it off a PLC, it's going to be set to Ethernet IP. Now I can show you that right now. If I actually run this drive, it's going to run based upon the actual speed I put in. So I'll start it, and you'll see I can change the speed of this drive based upon the speed pot that I have, right? Okay, so now in the same sentence, I'm going ahead and changing this to step logic, and it's going to actually stop, right? Because now it's going to be referencing the step logic. Now I'm going to shut the drive off in the meantime, but I wanted to show you that if you're using step logic, if you're using it for a batching station or a batching system, and granted, batching systems are used in many different atmospheres. They're used in like pulp and paper, they're used in food and beverage, they're used in makeup industry. Batching systems are widely used and widely spread, so having the variability and having this function is very helpful. So with that said, we've taken some logic that we did later in the course, so please don't jump ahead. Just feel free to understand that this is logic we did earlier in the course. And what we did is we've added our parameters to our drive, to the data that we can push to our drive, that we can push the time limits of the set mixing time, right, to our actual drive. Now, one thing I want to explain to you is if you're doing this from a PLC, right, you're actually communicating from your PLC to your Powerflex 525 drive, you're going to need some kind of communication like a control relay or something like that, like an ice cube relay that your PLC can turn on from the coil of that ice cube relay. And what you would be doing, in our case, we're using digital input 2, you would wire the port or digital input 11, which is the 24 volt DC. You would wire that on one side of the normally open on that ice cube relay, and then you would wire the other side, in our instance of the training, to digital input 2, which is what we're using to transition our actual step logic, right? So in our instance of using the step logic, we used digital 2 and we used the 24 volt. So I'm taking that through a switch, right? I just have a normally open push button, and I'm pushing the button every time I wanted to change states. In your case, you would wire this through an ice cube relay, right? So that you would close the relay from the PLC control, from an output control from the PLC. You would close it from there. Then it would close this contact on that ice cube relay and then change the state of the actual step logic. So that's one thing I want to note here. And I'm showing this in an instance of, say for instance, you have a big batching system, and like say you have an HMI on one side and you have a push button on the other to give the operator a variability to say if they're adding ingredients on this side, they can push the like the push button or push button station or something like that, like which would be again a normally a normal input from your PLC. Or if they're on the other side, say for instance, you can actually have them use the HMI, right? So either or, they can use that to change the actual step logic, right? So this would be the step logic change, again, controlling that relay we just talked about. So Now you may be wondering, how am I getting these tags and these variables in here? So I'm going to show you that. We're going to save this. I'm going to go offline. Now the reason for this is what we're changing, and I'll show you this. What we're changing in here is the format, right? So if we come over here and we pull this up and we go to device definition, we want to come down here to format, our connection format, and the inputs and outputs. And feel free to, we're going to go through all this tag structure and everything through the whole course. I'm going back answering a question on how you would control this batching station through digital inputs through an actual PLC. So when it comes down to it, I'm showing you how do you get these tags into this. So note that right here, your connection format, you can select different things you want to use from the drive. So in this instance, I'm getting, and the inputs would be stuff you're getting from the drive, right, to your PLC. The outputs are going to be stuff you're taking from your PLC and sending to the drive. Okay, so in order to do that, in order to change those, you have to go offline. Okay, and you go to device definition, you go to connection format, you're going to come over here to outputs. This is where you would change your output, like your step timing, right? And generally speaking, in your step timing, in the instance that we're giving of a batching station, we're saying, okay, so we want the button to be pushed when we want to change states. We want to change from this step to this step, and we want to allow it to run for a set period of time. So we're saying we just drag this down and we come over here and we select logic, and in the logic we just select step logic time 1 for our very first one. The next one would be 3, the next one would be 7, and the next one would be 5 and then 7. Now the reason we're skipping is because of the simple fact of we're getting the whole spectrum of all 7 steps, right? We're saying I want to be on for a set amount of time, I want to be off until the button is pushed, or I want to be off until the button is pushed, then I want to turn on and then run for a set period of time. That would be using step 1. Then I want to be off, which would be step 4 or step 2, and then I want to, when the button is pushed again, I want to go to step 3, and then I want to be off after the time's over. I want to be off on step 4 until the button is pushed. Then it's going to go to step 5, and then when the again the same process repeats over and over. So this is how you would actually, I'm showing you how to set that, right? I'm showing you how to set the actual tags you want to pass data to. Now with that said, we can close this module, and to show you this a little bit deeper. Now again, we talk about tag structure later in the course, so I don't want you to get too far into this, but I want to show you this as well. So we're coming into here, you have your actual I/O that you put in for the drive. You automatically get some things, right? This is your input data, the stuff you're getting from the drive. Your output data is where you're going to have your newly added step logic timing, right? As you see, we already have times in here. All I did was add this in here real kind of quick and easy, just to show you, because if I were to program this as we did it, it would take a lot longer, and the video would probably be like anywhere from 45 minutes to an hour. So what I wanted to do is keep it simple. And what I'm saying here is, I'm saying, okay, in the HMI, I'm allowing the operator to actually input a value. I'm saying, okay, so you want the first step to actually run the mixer for 60 seconds. Okay, so 60 seconds, you need to actually equate that. You need to have a multiplier of 10 so that you get the proper indication of what you should do here. Even though it says 600, if you go back up here and you go to program and you go to logic, you can see that that changes. This very first time step right here is 60 seconds. Now if I change this in my PLC and I change to 6 seconds, it's going to change to 6 seconds. Actually, let's, oh, we're not online yet. Okay, I'm sorry. Apologize for that. Let's actually go online and make sure we make these changes while we're online so you can see that stuff working. So if I were to change this, so keep in mind this is 60 seconds. If I were to change this to 6 seconds, right, it changes to 6. this is 6 seconds, right? So keep in mind whatever we put in here. Now the multiplier, the reason I like to do the multiplier here is because it's easier to control, and plus it keeps the HMI really simple. So say for instance you wanted to have again 1 minute, or how many seconds you want to run for the batch, the first section, right? 60 seconds. The next one would be 5 minutes, which would be 300 seconds. The next one you would want to actually batch for, like say 10 minutes. The last one you would want to batch for 60 seconds again. Now this is just an example of a batching system, right? Now for the sake of what we're doing, we're going to keep these pretty low. We're going to keep these at 10 seconds. I'm going to keep this at let's just say 30 seconds, and we'll keep this one at 30 seconds and this one at 10 seconds. So this is only because I want to illustrate to what we're doing here, and you can see this all changed here, right? So you may be asking yourself, how do I have the actual how do I actually have this set up, right? So I'm using a velocity wizard, and in the velocity wizard what I did, and I'll show you this so you understand. So I'm going to come in on step 1 or step 0. In my logic, I'm waiting for my input, my digital input 2 to be on before I transition to the next step. Okay. Now in this step, in the step 1, I'm waiting for digital 2 to be off and the time to expire. This time is getting this time from the actual PLC data. Okay, that's the data that we just got through showing. So this time is the time that we put in this spectrum right here. So again, this is that first time right here. So this would, now if I came back and actually open this again, it should change, but it won't change live. So this comes in here. Now this says 20 seconds. So you see that? So again, what we're doing is we're changing our data here. So let's put this back at 10 seconds, just so you can see that. What I'm trying to illustrate here is the fact of what you're pushing, the data you're pushing from your PLC to your actual logic, your step logic, does actually coincide. So in the instance of what we're talking about, in step 0, I'm waiting for the logic input 1 or logic input 2 to be on, to be a true state, okay, before it transitions to step 1. Then step 1 is going to run, it's going to come down here and it's going to run the time that we decided it should run while digital 2 is off, meaning the button's not pushed. Then over here on the very next step, which is the time frame that the operator would be adding the ingredients in the system, it would be the next step, and that's saying, okay, now after the ingredients have been set, the operator pushes the button again, then it would change to the next step, which would be step 3. Then it would run the batch for the set time with the push button not pushed, right? And let's change that back to digital 2. And then this would be the step 4 would be adding another ingredient, right? When they're done adding the ingredient, they push the button and it would transition to step 5. And in step 5, it would run the set time that we specified. Okay, and then while digital 2 is off, which the button is off or the control relay is off, right? And then in step 6, we're saying they're adding the last ingredient before the final mix, before the process is over. And then when they're done, they're going to push the button and it's going to transition to step 7, which is going to run for the set time that we decided, 10 seconds. And then digital 2 is off. Now we're going to click next. No changes have been made because obviously I kept this the same. Now I'm doing this, now normally you wouldn't have your mixing time so small. I'm doing the mixing time so small right now so that you get an instance of when we run this. I'm going to show you the whole process as we run it. So what we're going to do is we're going to start the system. Okay, so we're going to start. It's going to wait until I push the button. So meaning the first and foremost, the operator would be adding the ingredient, and as soon as they're done, they can push the button. They would push the button. Now it's going to run for the 10-second time frame. Now it's going to run for 10 seconds, and then it's going to stop. Now this is with the button not pressed, so it's ran as 10 seconds, it's stopped. This would be the operator stopping what they're doing, putting the next ingredient in, right? They would put the next ingredient in, so it's completely safe, nothing's running, nothing's turning. So then they get done putting the ingredient in, then they hit the button again. Now it's going to run for the 30-second time period, and it's going to run again at the set speed that we put it at, right? So we determine the set speed based upon the actual step logic that we did, right? So this is kind of working with the Powerflex 525 working in conjunction with the PLC controls. Really simple, really easy, but again, really effective, right? So it's going to run this 30-second time period. After it runs this 30-second time period, it's going to stop again. So it just stopped again. Now it's going to, at this point in time, the operator will be putting the next ingredient into the actual batch, right? So that as soon as they got done, they put the last ingredient in and they said, okay, well, now I want to go ahead and do another mix. They push the button, they start the mix. You can easily see that it starts. So this is the way you would actually use step logic, right? And this is a good use case, right? So I'm not saying that this is only for batching, but I'm saying this is a good use case is for batching, right? So at this next section, right? So this after this 30 seconds is over, what it's going to do is it's going to stop. Then the operator would put in this last ingredient, right? So it's stopping right now. The operator is going to put the last ingredient in as soon as they're done, right? And they're in a safe manner. They come back and they get done. They're going to hit the button one more time, and they're going to go in, and then it's going to go to run the last 10-second batch, right? Or 10-second mix time, right? Now, what I wanted to show you too is if I come in here and now I come into my PLC and I say I want my real mix times back in there. I want 60 seconds. I want 300 seconds. So this would be 1 minute. This would be, say for instance, this would be real world batch systems, right? So a real small batch, but it would be a batch system. So we say 1 minute the first batch, or the first mixing time. We want to say 5 minutes the next mixing time. We want to say 10 minutes the next mixing time. And for the last mixing time, we want to do it for a minute. So in that instance, again, we would just come in here and start. And then we would do the same process. So now we've essentially changed the actual atmosphere. And anytime, note too, that anytime you stop the system, it's going to actually stop, right? So if I were to actually push the stop button on the actual machine right now, it would stop. Now this is a training environment, so obviously all I have to do is push the stop button on the trainer. But again, what I'm trying to illustrate here is now it's running a completely different batch, right? So no, it's no longer running the 10 seconds that we were running. It's now running the 60 seconds. So I'm going to let it run its complete 60 seconds just to show you that it did take the parameters that I just changed. I just changed them live, and you can see it. This is the reason why you would use it, right? Because obviously you would say, okay, well now I'm grade changing, right? So you could, now I didn't put any kind of logic in here for like a recipe system or anything like that, but that's what you would generally use, is you would use like a recipe system. So it's ran at 60 seconds. So now we're operator going to put the batch in. They're going to start putting more ingredients in, right? They're going to put their next ingredients in, and then they're going to hit the button again. Now it's going to run for 5 minutes. Now I'm going to save you the sake of not watching this for the next 15 or 20 minutes. I'm going to save you the sake, and we're going to show you this stopped. So if I were to stop it, it would actually stop. Now all the stop and start controls are based upon up here, right? This is all stop and start controls. So all of the actual commands for start, stop, and clear are coming from my actual PLC controls. Now, even though I have the speed reference programmed to be communicating over Ethernet, I'm no longer using that, because what I'm doing in my parameters is I'm coming in my basic programming and I'm saying I want to use step logic. I want all my speeds, from velocity speeds and timing and everything that I'm doing, I want it to be done off step logic. And in my step logic, I'm controlling the speed and the frequency on the steps that I'm mixing or I'm running in this instance that I'm showing you. I'm doing that based upon the actual preset that I have programmed in here. Now the preset is done off the wizard. That's the easiest way to do so. So I'll just go ahead and say that. Just make sure you, like say for instance, if I want to change it, I can change it here. So each one of these I have set to basically batch for and run for a set time, but I also have them running at a 60 hertz. So with that said, this is just a good use case and a good illustration of how to use this. I know this video kind of ran a little bit long, but it was very, very informative. Hopefully that answered the question as far as how would you use this and utilize this with a PLC controls. And again, I should have built some recipe logic and stuff like that. Treat this right here as your recipe logic. So you could load that in. You could have like 5 or 6 recipes loaded in from your HMI, and then have that either HMI controlled recipes, or you can have that through PLC controlled recipes. The reason I didn't do recipe logic and stuff like that is because it could be done through either or, right? There's a wide variety of situations that could have happened. So with that said, hopefully that was very informative and helpful, and we'll see you guys on the next one.